Hello guys, welcome again. In this video, we are going to build a whole RAG system using N8N. Before building the actual chatbot, we are going to understand every step of the RAG system, how it works, and what are the important things you should understand before building any RAG system for your next AI agent or any AI system that you want to build or integrate with your existing software. So let's get into it. So firstly, I would like to say, please make sure you have speed up your video to 1.5 to 2x. It will help you to understand me better in a better pace. Okay. So let's understand what is a RAG. RAG means Retrieval Augmented Generation. This is just the full form of it. But if you understand in a high level, it is similar to the database for the AI. So why are we need a database for AI? There are two important use cases for this. One is to decrease down the hallucination and the costing of it, and to increase the accuracy and the domain specific knowledge of the AI models. Let me explain it how. So for example, if you go to the ChatGPT, let me go and search here for the ChatGPT. Okay. And if you are going to search for the GPT here, and ask anything, I'm just going to use the temporary version. And if you're going to ask anything, like say, what is, let's say something that it doesn't know. What is Chandra? Let's say I am Chandra, but I am asking it. So it is saying it's an Indian culture and mythology. Chandra means the lunar divinity or anything specific. It is not normal for me if I am building a software for my users, and if users asking who is Chandra in the company, it is not going to answer the specific things, and it is telling me in a very confident manner that it knows everything. But this is not something very useful whenever you are building a chatbot and the support agent. So what we need to do, we need to build a RAG system for our use cases. RAG will allow you to deliver the good quality AI chatbots to your customers in a very well manner. So first understand how this RAG system works. Okay. Before diving into it, first understand how the RAG system works. So RAG system works in a two small process. If you see in the N8N, one is the adding data to the vector database, another is retrieving the data from the vector database. There are the two important scenes here. First thing is to train your LLM model with a specific kind of data set. But here we are not directly training to the LLM model. Instead, we are adding the data to a vector database that understands or that LLM understands very well. Okay, so we are building the data for the vector database, which is very easy for the LLM models to understand. Okay, we will define each step by in a clear manner. Okay, so first understand how this vector store works. In a vector store, if you see, we have the first process. If we just cover the first process, there is small step. First thing, you should have a specific kind of data for you. For example, if you want to train your data with like data sources like PDF files or the website links or text or any kind of a specific content, you should have the data. And it could be any unorganized data. It should not be organized. It could be any kind of text data. And you have to do what you have to do whenever you are going to upload this data to your vector database. So you have to convert or you have to go with the small processes. One process is called chunking. You have a whole lot of data. Maybe you have thousands of pages of data. You don't want to add the whole data to the vector store directly. Instead, we will completely divide the whole data into small chunks. Maybe in the process of 100 tokens or 200 tokens. We will define the tokens later. But you just understand, like if you have the 1,000 pages of data, you just going to divide into each paragraphs so that you can easily store in the vector database. And we are going to describe the vector database, how it's going to look. But this is the first step. Second step is called indexing. So indexing, it's called like when you have the chunk of data, you have to index that data in how the vector store wants it. So vector store means the data is not stored in a very regional way, or you can say it's not stored in a very simpler way as the previous our NoSQL or MySQL databases stores it. It stores the data in a vector form, in the form of numbers, as in a mathematical expression. If you say in the 2 dimensions or the 3 dimension or multiple dimensions, where it stores the data in the form of numbers. So we have to convert these numbers into the embeddings, and for converting those numbers we have to choose the specific embedding model which is provided by the different companies. So for example, let's take OpenAI giving their own embedding model called text embedding 3 large or 3 small. These are some common embedding medium which you can see also in whenever we are going to create the Pinecone vector database. Okay, so this is something that is important. This embedding is an important process where we are going to convert the text data into the vectors, and the vectors now going to store into the vector database, similar to the Pinecone or any other kind of vector databases. Okay, this is the first process. In this process, we are going to divide the whole data and store the data into the vector database. Now let's move to the second stage. Second phase is when user going to ask the questions, and our LLM model is going to answer based on the data that we have stored in the vector database. Okay, so in this manner, you can see it's a normal process. Whenever user asks a question, it is going to generate the content based on the data inside the vector database. But it is not so simple. It is also have a small tweak while retrieving the data. So let me explain it how. Okay, so here is a small diagram which I would like to explain in a very clear manner. Okay, first thing, whenever users put some input, for example, if I am asking who is Chandra and it is do not know who is Chandra is, then it is not going to answer the relevant thing. So this RAG system, this works is actually we have to convert the user input into another form of embedding. So basically you can understand, if we have already stored the data in the form of embeddings, now we have to convert the user data in the form of embeddings so that we can do a similarity search inside the vector database. So inside the vector database, there are a few methods, one of which is we call the similarity search, where we are going to find the nearest data according to the what users asked for. So we are going to figure out and collect that small chunks that we have divided, and going to collect the indexes or the ID from the vector database, and going to return that data and or what are the IDs we have stored, and that convert and give it back from the vector database. And now we are going to use here we need one more method to convert those embeddings to the text again. That is basically is completely dependent on the vector store database that you are using. And now we have to define the prompt. Like now we have to define the prompt. Okay, this is something user asked, and now this is something that we have collected from the vector database, so that we can add more context to the LLM model. And now we send this data to the LLM model, and LLM model respond back to the user. This is a generic flow. This is a whole you can say the 10,000 feet overview of this whole flow. There are a whole lot of things to do in the practical manner, if you understand, in the programming manner or in the AI generation world. But you just understand this is sufficient knowledge that you need to build an N8 and the system similar to this that I have built. And you can build this system actually for the much more bigger and complex processes, to understand and to build a more robust system, to create more accuracy and more domain specific data or domain specific agent for your use cases. Okay, so let me guide you how I have built this. Actually, I have created one more video similar to that, but in this video I'm going to say or clear this out how you can build this on your own. Okay, so first step is to build the system for uploading the data into the vector database. Okay, so first understand how we have built this. So we are using the tool called N8N. If you're not familiar with the N8N, you can watch my previous videos where I've explained how we are using N8N to build automations and workflows. Second thing, we are going to use the Pinecone vector database, which is going to store our data into the database. Third thing that we need is Google Drive access, which is basically everyone uses Google nowadays. So you can access your own, use your personal Google Drive to store your files and data, so that we can train their data to our LLM model. And we will build a chatbot assistant, which is personal to me only. Okay, so it is a specific database which is personal to me. I am using my personal resume or CV for training this data for this presentation only. Okay, so let's dive into this process. So first step is to add the vector database. So here I have used the N8N model, where I have just created one trigger where if anything changes in this drive, it is going to take the data inside one folder called AI automation, if any file changes here, it is going to collect the data. If I'm going to fetch this event, it is going to give me the relevant answer from the Google Drive. Okay, for connecting the Google Drive, you have to add your Google Drive from here. You can also add your connecting credentials. So make sure you are following the specific documentation, or you can also watch my previous videos where I have explained how you can add credentials for your Google Drive, or you have to just enable the Google Drive from your Google services account. Okay, this is it. You have to just add your client ID and secret and log in using the OAuth system. This is the very best use cases. You can follow the last videos, or you can follow another videos on the internet, but this is a simple process. I don't think you have to worry too much. Okay, the next thing, because I have already added it, you have to just choose the trigger on the specific folder changes and choose the folder and select the file created options. Okay, now this is it. You have to just click this button to test like if the data is fetching properly from that folder or not. Okay, so whenever you are going to add your more files, your vector database is going to be trained on that. Okay, next step is to download the file. So you are just fetch the file from the vector from the Google Drive. Now you have to download the file to your N8N. For this, I am using this ID, where I have just chooses the ID from this space where I've just recently uploaded the data, and I'm just selecting this file section and by ID and just dragging and dropping this like this. And now I can test this setup. And now you can see my N8N is fetching the data, and you can view this is the CV I have uploaded from my drive to N8N. Okay, very good. Now the third step is very important. I have to just store this data to the Pinecone vector database. So what is Pinecone vector database? Let's understand it. So I'm in the Google search and search for Pinecone. Okay, I am going to search this Pinecone vector database. So here, and if I click on this button, you can see this is the build knowledgeable AI. This is the first line of this, and the vector database for scale and production. And you can just simply log in into this account. You don't have to pay anything. It is free for your use cases for the initial purposes as of now, and it is very good, I would say. Okay, now you have to just create your account. You can log in. I have already logged in into it using my Google account. You can also log in your personal email or Google account, whatever you like. And you have to do the two things here. One thing is to create your API key. This API key allows you to connect your Pinecone vector database with N8N. So you have to just click this button, name the API key, whatever you want to add, and just create the key. Copy the key, and make sure you have properly copied the key, and go and add the node called Pinecone vector database. And here you can add your API key directly, and just you have to paste the API key simply and just save it. Once you save it, you will find like there you have the options to insert document. You have to just choose the insert document, and you have to choose the option of the in which index you want to upload the data. Right now, if you see, there are two indexes are showing. These are the indexes coming from the database section where I have created these two indexes. Okay, so if you are not seeing any indexes, you have to just create one index. It is going to take little time, so don't worry about it. You have to just name it in a single letter, or make sure it is a single word. So use hyphen or underscore for naming this. Don't put any spaces, and you have to choose the embeddings. Make sure this is embedding what we were talking about in this video earlier. So you can see this is the embedding model we need. Okay, so well, it's not going up. Okay, so this is where we need the embedding model. We are using the text embedding 3 model, so you can choose according to your use cases. Okay, so here we have to use the text small embedding. This is a most cost efficient AI model, and for this you also need the open API key. Not for now, but later in this video. But you have to just click this option and just leave as a default, and then just in the starter plan you don't have to pay any money, and just create the index. Okay, this is it you have to do. After some time you will see your index is up and ready like this. You have like all the default embedding as here. For now, I am just going to delete this data so that I can start from you with scratch. So I'm just going to add this Chandra info, copy this, and delete this, so that you can see this is a blank database right now in this my Pinecone, similar to you. Now you have to do a few more things here. Now inside the N8N, you have to add your namespace. So what you have to do, go to more options, and you have to choose the options called Pinecone namespace, and you have to add the Pinecone namespace. This is the space name where you are going to store the data. It's like a folder inside the Pinecone vector database where your data is going to be stored. Okay, now you have to do few more things. You have to choose the embedding model here. So embedding model, I'm using the OpenAI account and using the same model as I've used inside the Pinecone from here. Okay, now choose the model. I am using the text embedding 3 small, and make sure you are using the OpenAI account here, and you have to add your OpenAI account. So follow these instructions given in the N8N. It's just simply you have to just create your OpenAI API account. For the first users, just giving the free credits so you can use those credits, and you have to just put your API key. Forget about the organization ID, it's not for you, and just add your key and save it. Simple as that. Now you have to do the next thing. You have to add the default data loader. So this is the method. It's going to come here in the process whenever you are doing the chunking part of it, okay, or the indexing part of this. So somewhere around. So what you have to do, you have to just choose which kind of data it is. So it is going to not the JSON data, it's a binary data. So because we are choosing the file, and it is going to like load all the input data, whatever the file is going to come, just going to load all the data, and we have to just say automatically detect the format of the file. Okay, so automatically detect, choose this option for us. And the third option that you have to choose is the text splitter. So the text splitter is something that you have to use. So use the recursive character text splitter, is the most recommended splitter, and this is it. You have to choose. I'm going to run this once so that you can see I have uploaded the file, I have downloaded the file, and let me check which. Okay, I'm using the default, and just test the setup. It is going to execute the things. Right now there are no records and there are no namespaces. You can see here it's going to default, but after some time this process once complete. Okay, node executed successfully. I have to just refresh this page. It's taking a little time. So you can see after some time, like my data has completely stored in the database. Okay, so what's taking time? Okay, it's fetching properly, and inside the namespace you can say Chandra info, and it has 8 records, means 8 chunk of data. Now you can see here is the chunk data. I have added one file, but it is completely, you can see it is completely breaking into the paragraphs, and it has all the ID. This is the index ID, and this is the blob type, like from which file it has collected, and what is the author name, and everything that it knows, it automatically detected from the PDF metadata, and it is putting directly into my vector database. This is a very important information which this vector database is doing automatically for me. Okay, now you can see this is, I have 8 indexes of data, and now I have to use this data to train my AI element, to train my AI agent chatbot to build this data. Okay, now move to the next step. This is the next step. Here what I have done, I have to retrieve the data from the MongoDB. For retrieving the data from the MongoDB, I have added one node called the chat message received. This node is actually basically the simple node. I'm just going to for this purposes, I'm going to just share this. So for what I'm going to do is I'm going to just copy this URL, going to paste this URL over the domain like this, and now you can see my chatbot is here. I'm just asking, hi there. Oh, sorry, not here. I'm saying hi there. Okay, so this is my chatbot, and inside this chatbot you can see this is giving me the answer, hello, how I can assist you. Okay, so now inside this chatbot I have to do few more things. So let's go to the N8N, and here I'm just going to test this. So I'm just opening the test chat, and now you can see the workflow working here. So I'm asking, hi, who is Chandra? Okay, so we are just testing it, and you can see how this process working. AI agent is fetching the data from the LLM model, and you can see the vector store, the embedding. Now you can see also in the embedding output, you will find this is the vector numbers are coming, and the vector database is now converting using the similarity search and giving me the relevant answer, and this answer is coming from this. And you can see that it seems you are referring to the Chandra Prakash Tiwari, which is my name. I can assist you. Yes, tell me more about him. Now it is doing the similarity search. Sorry if Chandra Prakash Tiwari, if you're looking for, so actually this is up to the prompt. I have to just upload the prompt, but you can understand it. So let me walk you through how it works. So after the chat node, I have added the AI agent node, where I have added a system prompt, where I have said, okay, you have to do the few things according to these use cases, and you have to add your data based on the user input. This is the user input, and make sure you have added, like you have to collect the user information. So I have to mention collect user context from the vector database tool attached. Okay, I'm just taking this so that it is using the tool properly for adding the context. Okay, now just leave it for now. Next thing, I have added one chat model. I am using the OpenAI chat model here, which is just the chat model I have used. It's a simple, you have to just add the OpenAI account and choose. I have chosen the O Mini. This is the cheapest one. And now you have to use a simple memory. Simple memory, just basically it is going to connect, like it should have the context of all the communication that you have. So it is going to store all the data that you have asked so far. So it is based on the session ID of the chat, what we have used. The third thing is the tool, which this tool is going to use if we have to use the questions and answers and question with the vector store. So this is a tool, it's allowing you to ask the question be on your behalf, and it is going to collect the data from the vector database and going to respond it back. So you can see I have asked the query Chandra Prakash Tiwari, and it is going to answer the Chandra Prakash Tiwari, the SaaS entrepreneur, everything from here. So it is basically answering everything based on this. The two things you have to add is add a chat model. Basically, this is going to connect all the things from the vector store database. And second thing is Pinecone vector store. And here you have to do the few things. You have to just add the embedding option. This is a simpler already that you have chosen. So I have used the text embedding as previous one. And the second thing you have to do is to just make sure you have added the Pinecone namespace, from which Pinecone namespace you have to figure out the things. You can also make it dynamic, but I'm just making it static for now. And make sure you have chosen the right Pinecone index name, and retrieve the document as a vector store chain tool. Make sure you have chosen the right options from here. Okay, now everything is up and ready, and now you can ask the data based on your context. This is something I have built for me. Make sure you have written the proper prompt, because without this proper prompting, it is not going to collect the right context. Because if you see here, if you go back and see here in the prompt section, you can find, like, this is the prompt where this LLM model is going to respond you back with all the settings here. Okay, so the prompt is a major important thing. So make sure you have given the proper prompt to your AI agent. In this video, this is it, guys. I have created a whole lot of things for you today, and let me know if you wanted to explain me anything specific for you. I will guide you specific step by step in the next video. Thanks for watching, and keep improving. Thanks a lot.